Let us look at question number 41 now, students. In the given reaction sequence, so we have a tertiary amine which is allowed to react with CH3I followed by Ag2O moist. Students, the examiner seems to be interested in the Hofmann's exhaustive methylation and then Hofmann's elimination. So in the first step, we are going to have the formation of the structure where there will be a methylation present at nitrogen. So we have the formation of a quaternary ammonium salt, and now when it is allowed to react with Ag2O moist, so the Ag2O moist will cause Hofmann elimination. So the H which will be present here shall be extracted, leading to the formation of the structure. So this is the end product P which is formed, and we can see that the degree of nitrogen in the structure is 3. So out of the given options, we have to select the third statement where it says that P is a 3-degree amine. Let us look at the next question. Question number 42. In the given reaction, so we have been given hydroquinol which is allowed to react with Na2Cr2O7 in presence of H2SO4. So this reagent will cause oxidation of this quinol, leading to the formation of paraquinone. So we're going to have the formation of this structure, which is represented to us in the question as the structure A. So the examiner seems to be interested in which of the following is correct about A. So in the first statement it says A contains 5-membered ring. This is incorrect, students. A contains a 6-membered ring. If you look at the second statement now, A does not show tautomerism. So this is correct, students. There are no enolizable hydrogen present in the structure, so A cannot show tautomerism. If you look at the third option now, A is a carboxylic acid. This is also incorrect. A is a ketone. And in the fourth statement, the examiner says that the given oxidation does not take place. This is also incorrect, students. So for this question, we have to mark the second option as the correct answer. Let us look at the next question. Question number 43. In the given reaction sequence, so we have been given a carbonyl compound and it is allowed to react with LDA. So students, we know that LDA is a base and it will extract an acidic alpha hydrogen. So this hydrogen shall be extracted, leading to the formation of a carbanion at this position. And now this carbanion shall attack the benzyl bromide which is given to us. So this will make an SN2 attack, causing this Br to leave. So we're going to have the formation of the structure which is represented by the letter P in the question. So we have to identify the structure of P, and if you look at the options very carefully, we can see that the correct option is given to us in option 2. So for question number 43, we have to select the correct answer as option 2. Let us look at the next question. Question number 44. In the given reaction, the predominant product formed is. So we have been given a structure which is allowed to react with the ethoxide ion. Now we know that the alpha hydrogens are acidic and the molecule is symmetric. It does not matter which alpha hydrogen we choose. So for simplicity, we can assume that let this hydrogen be extracted. It will lead to the generation of a carbanion at this position. This carbanion shall attack intramolecularly and cause this ETO minus group to leave. So we're going to have the formation of a 5-membered ring in this case. And the carbonyl shall be present at this position. This is the new bond which is formed. And the other ester group shall be present. So this is the product which is formed in this reaction. And if you look at the options, we can clearly see that we have to select the second option as the correct answer to question number 44. Let us look at the next question. Question number 45. When 44.8 liter of C4H8 is burnt at STP in presence of air rich in oxygen and all available oxygen is used up, 89.6 liter of CO2 gas at STP and 72 gram of water are produced. So the examiner wants us to comment on the maximum volume of the oxygen gas which was available for the reaction. So if we talk about the combustion of butene, we have C4H8. It will undergo combustion to give us CO2 and H2. If you try and balance this reaction, there will be 4 CO2, there will be 4 H2O, and there will be 6 oxygen molecules. Now if you look at the information which is given to us, so we have been told that at STP 89.6 liters of CO2 are formed, which means that the moles of CO2 is equal to 4. And if we talk about H2O, it is given to us that 72 gram is formed. So this also leads to the moles of H2O being formed equal to 4. And if we talk about the C4H8 which was given to us, so we had been given 2 moles as the volume is 44.8 liters. So looking at the data, we can clearly see that the oxygen has to be the limiting reagent in this case. It is the LR, which stands for limiting reagent. And if you look at the stoichiometry of the given reaction, we can see that there must be 6 moles of O2 present in the combustion mixture which was given to us. So if we talk about the volume, so we just have to multiply the 6 moles by the molar volume, which is 22.4. So this gives us a value of equal to 134.4 liters. So students, for this question, we have to select the first option as the correct answer.